This is Timbuktu. If we add 1, we get Timbuk3. And adding 1 again gives us Timbuk4. But what do these plus 1s mean? We can do math on the globe using a framework called the eyeball. Well, people usually call it the Riemann sphere, but I prefer the term eyeball because it's a ball that has the imaginary number I. And it has other numbers such as pi, pi to the I, and I to the pi. Any complex number can be mapped onto the eyeball. And we can map onto any sphere, such as a marble or a 33rdsness ball, but the globe is my favorite. It has a distinct pattern, so you can always tell where you're looking. And this map means that each city has a number. Los Angeles is -1.7 plus 0.9i. Tokyo is 1.26 plus 1.49i. Shanghai is 1.51 plus 0.93i. But how do we find these? What number is Dubai or Amsterdam? We can find the values using a stereographic projection, a stereoject for short. We start by making a grid of complex numbers. The x-axis has all the real numbers, such as 1, and the y-axis has all the imaginary numbers. To perform the stereoject, we'll put the globe on top of the grid, right at the origin. To find the Dubai number, we draw a straight line from the North Pole through Dubai. This line hits the grid at 1.28 minus 0.89i, so that's the value for Dubai. Now let's stereoject Amsterdam. We draw a line from the North Pole through Amsterdam and find where it hits the grid. That's the Amsterdam value. And now we can calculate Dubai plus Amsterdam. We just add their values to get 1.53 minus 3.81i. But where is that on the globe? We need to reverse the stereoject. We plot our number and draw a line from it to the North Pole. The line intersects the globe on the coast of Finland. So that is Dubai plus Amsterdam. Let's try some other cities, like Singapore plus Sydney. But this process of drawing lines is tedious. It would be nice to write a program to do this automatically. So let's make some instructions. To calculate numbers based on locations, we just need to use this set of equations. And yes, the variables are shapes of some nations. I thought it was fitting, based on the topic of the video, you know? Anyway, Singapore has a latitude of 1.2 degrees and a longitude of 103.8 degrees. So we'll plug them into the equations, do a little algebra, and we get 0.99 plus 0.24i. We can do the same for Sydney to get its value, and then calculate Singapore plus Sydney by adding their values. But where is this? To go back from numbers into locations, we now use this second set of equations. This sentence will rhyme to build expectation, but this one will not, to cause you frustration. Oh, wait, that did rhyme.
Dang it!
Let's plug in the value for Singapore plus Sydney, then do a little algebra, and we get these coordinates, a location just north of the Philippines. And after programming those instructions, we can easily try other combinations, such as Portland times Mumbai over Manila, which is here. And by canceling some letters, we find that this is Port Dumb, which is accurate because it's in the middle of the ocean! And we can use this canceling idea to find other cool places, such as Lononalom City, Jig Buses, Prar, Sumbug, Oi, Tontocraw, So Publi, Licky Bogo, Goovnoover, Jackataxic City, Krelban, Bagadadaddy, Uckadunch, and Busp. We can go beyond just cities. What if we use E, Euler's number? Multiplying by E gives us Eatlanta, which is up by Santa. And dividing by E gives us Captown, which is down by the Penguins. For any location, multiplication and division move in different directions. Multiplication makes numbers bigger, and the bigger numbers surround Santa, while division makes numbers smaller, and the smaller numbers surround the Penguins. But why? If we stereoject a penguiny point, the line will be steep, so it will hit the grid near 0. The value will be small. But a Santa-y point will have a shallow line, which will travel much further before it hits the grid. the value will be large. And so if we start at Timbuktu and add to get Timbuk 3, then Timbuk 4, Timbuk 5, and so on, the values get larger and larger, so they get closer and closer to Santa. In fact, the limit of Timbuk n as n approaches infinity is Santa. And that's because Santa is infinity. If we stereoject the North Pole, that means we draw a line from the North Pole through the North Pole. But those are the same point. There are infinite lines to choose from. There's no well-defined values, so we say it's infinity. And this means that the eyeball is not just the complex numbers. It's a compactification of the complex numbers, which basically means it has a Santa DLC that makes the set compact. This adds some cool new features, such as convergent sequences. In the plane, a sequence of points can run off to infinity, but on the sphere they will converge towards Santa. Any sequence on the sphere will have a limit point, because the sphere is compact. So next time that you're looking to make your complex numbers converge, consider using the eyeball. Thanks to the recent supporters of the channel. I made an interactive version of the globe where you can move around the input points to see how they change the output. Follow the link below to play around. There's also a link to a map of all the locations from this video, plus a few extras that I didn't mention. Wow.